Hi students, welcome to physics classes. Today we'll discuss laws of motion from the class 9th NCERT laws of motion. Today we'll discuss. In this list of topics covered are law of inertia, types of inertia, Newton's first law, momentum, second law, third law, impulse, law of conservation of momentum. First topic is law of inertia. Now, if an object is at rest, it will be in rest. If any force acts on it, it starts moving. If the object moving, it will be in motion continuously. If any force acts on it, it will come to rest. That is known as inability of that body. The body by itself, it can't change its state. A body on its own cannot change its state of rest or state of uniform motion along straight line. By itself, it can't change. An external force should act on it. This inability of a body to change by itself its state of rest or state of uniform motion along straight line is called inertia. It is its inability. By itself, it can't change. Inertia means resistance to change. Inertia means resistance to change. So it is not able to change. Here, inertia is not a physical quantity. Inertia is not a physical quantity. It is the property of the body. It is the property of the body and it depends on mass of the body. If the object has more mass, it has more inertia. If the object has less mass, it will have less inertia. Object has more mass, it has more inertia. Now, if an object is having heavier, more mass, to move it, it is difficult. To move it, we need to apply more force because it is having more inertia. If an object has less mass, it will have less inertia. If an object has less mass, we can move it easily. So inertia is not a physical quantity, so it is not having any units and no dimensions. Now we have three types of inertia. In that first one is inertia of rest. Inertia of rest means it is the inability of a body to change by itself its state of rest. If a body is kept in rest, it try to be at rest. By itself, it can't change its state of rest. This means body remains at rest and cannot start moving by its own. If any external force acts, it will change. By itself, it can't change. Now example for inertia of rest. Now if a person is standing in a bus, if a bus suddenly starts, he will fall backward. Lower part of his body is contact with the bus. When bus suddenly moves, he is also having same motion. Contact, no? Half of the body. Half of the body is moving forward, but remaining half, no contact, it will fall back. When a horse starts suddenly, the rider on the horse falls back. Even when we sit in the bike, on the bike, when the bike moves suddenly, if any suddenly moves, we will fall backward. Next, second type of inertia is inertia of motion. Here, the body by itself, it can't change from its motion. It is the inability of your body to change by itself its state of motion. That is, body in uniform motion can neither accelerate nor retard. If a body is in uniform motion, it travel in the uniform motion. It is not accelerates, not decelerates. By itself it can't. If any external force acts, it can. Now example, when we stand, same example also we can take. A person standing in a bus or train or sitting. If a bus suddenly stops, he may fall forward because lower part of his body contact with the bus or train. When bus suddenly stops, he is also getting stopped. Lower part getting stopped, but upper part is not having contact, no, so it will fall forward. That is inertia of motion. Next, when a fan is switched off, after switched off also it continue to move in the same. Slowly it is getting stopped. That is because of frictional. If there is no friction, it should rotate. That is also because of inertia of motion. Next, third one is inertia of direction. It is also an inability of a body to change its direction by itself. It is not able to change its direction also. It is not able to change its direction also. When we sit in the bus, if bus takes sudden turn, we will fall sidewards. Next, when a wheel is rotating, for wheel small mud particles are there, then which direction it will take? Tangential direction it will take. That is also because of inertia of direction. Now a person sitting inside the car, if he takes sudden turn curve, then he will fall side side of the person. Okay. Next, based on this law of inertia, Newton given his first law. Newton given his first law based on law of inertia. What is law of inertia? By itself, it can't change either its state of rest or uniform motion. Now we see Newton first law. Body continues to be in its state of rest or uniform motion along a straight line unless it is acted upon by external force. If there is no external force, if there is no external force, body continues to be in its state of rest or uniform motion along straight line. If it is at rest, it continues to be at rest. If it is in motion, it is continuous to be in motion. If no external force acts on your body, if there is no external force acts on your body velocity will not be changes. Velocity of the body cannot changes. So it moves with uniform velocity. If there is no change in velocity, then it is automatically uniform velocity. So when the body is having uniform velocity, no change in velocity, so it cannot accelerate. Next, momentum. Now, if we have bike and cycle, we need to apply more force to move them. For example, if bike is rest and cycle also rest, so to bring them to same speed in same time, cycle will come fast into the speed. Bike, it won't come because it is heavier. Without starting here, without starting, if we want to push them to bring same speed in same time, for which we should apply more force? Obviously for bike. So because it has more mass, we need to apply greater force. Even if a heavy body and light body we have, if they are moving, to get them into rest, if they are moving with same speed, to get them into rest, we should apply more force on heavy body than light body. So more mass, more force is required. Less mass, less force is required. So this shows the heavier body has more quantity of motion than lighter body. More quantity of motion than lighter body. Now, this quantity of motion of body is directly proportional to mass. If it is having more mass, more quantity of motion. Less mass, less quantity of motion. When it is having same speed, in all the cases we have taken same speed in same time. Next, if two bodies are having same masses, one is fast moving, another one is slow moving. So we need to stop them. For which we should apply more force? Fast moving body. Fast moving body requires more force to stop than slow moving body. So that quantity of motion of a body is directly proportional to velocity. More fast, more velocity, we should apply more force. Less velocity, we should apply less force. So this quantity of motion possessed by a body is known as momentum. quantity of motion possessed by a moving body is known as momentum. Momentum is the product of mass and its velocity. Mass of the body and its velocity. So momentum equal to mass into velocity. Product of mass and velocity. Mass into velocity. Mass is denoted by letter M. Velocity denoted by letter V. So P is a momentum. P equal to M into V. SI unit of momentum. SI unit of mass is kg. SI unit of velocity is meter per second. So momentum SI unit is kg meter per second. At the same time, CGS unit gram centimeter per second. If a body having mass m moving with a velocity v, its momentum is m into v. Now, if a force acts on a body, velocity of the body also changes, no? So, when velocity changes, momentum also changes. Change in momentum. Now, if a body of mass m moving with initial velocity u, after applying some force, final velocity is v. Then initial momentum mass into initial velocity, final momentum mass into final velocity. Then change in momentum, final momentum minus initial momentum, m into mv minus mu. M, if you take common, m into v minus u. Now why here velocity of the body changes? Whenever there is a force. Whenever there is a force, if more force you applied, more change in velocity. That implies more change in momentum. Less force you apply, less change in velocity. That implies less change in momentum. So the rate of change in momentum means in a particular time, change in momentum of an object is directly proportional to net force applied on the object. More force we apply, more rate of change in momentum. Less force we apply, less change of momentum. So when a force acts on an object, the object will accelerate. Pushing a ball, the velocity goes from 0 to how hard you push the ball. If you apply more force, more velocity. Less force, less velocity from 0 onwards if it is at rest. Now, rate of change of momentum, we can write a change in momentum by time taken. Rate of change of momentum equal to change in momentum by time taken. So F equal to change in momentum mv minus mu divided by time t. If you take m common, v minus u by t, and v minus u by t is rate of change of velocity, that is equal to acceleration, we know. Then F equal to mass into acceleration. Now Newton third law. Now whenever we hit the wall, as much force we apply, wall also opposing with the same force. And one more, when we are swimming, what we will do? We will push the water back. Whenever we are pushing the water back, water pushes us forward. That's why we are going forward. Even we are jumping from the floor, we will push the floor, then we will raise up. So every action, whatever we are doing, that has equal and opposite reaction. According to this law, for every action, there is always an equal and opposite reaction. The force of action and reaction always equal and opposite. Action and reaction always equal and opposite in direction. Magnitude of forces are same. Action force, reaction force, magnitudes are same, but their direction is opposite. Now examples: fishes to swim, birds fly. That is based on Newton's third law of motion. Motion of a rocket launching, we know large amount of gases they will release down. That gases will hit the ground, then ground pushes it upward, so rocket will go upward direction. Now here action and reaction never acts on same body. When we hit the wall or when we are jumping, we will push the floor pushes us, so we are applying action on the floor is applying reaction on us. So here action and reaction acts on two different bodies. Next, impulse. So when large amount of force is acting on a body very short period of time, large force acting on a body in very short period of time, that is impulsive force. For example, a ball hit by a bat. How much time it will take? Very less time. A nail hit by a hammer. When we inserting a nail in the wall. Now formula and units for impulse. Impulse equal to large force acting on short interval of time. So impulse equal to force into time. Impulse is denoted by letter J, force F, time T. So we can write F is m into A, mass into acceleration. Acceleration we can write v minus u by t, change in velocity by time taken, divided by t into t gets cancelled. So J equal to m into v minus u. Impulse equal to m into v minus u. As we know, m into v minus u is a change in momentum. So impulse is equal to change in momentum of the body. Now SI units of impulse. As we have formula impulse equal to force into time, SI unit of force is Newton, SI unit of time is second. Newton second is the SI unit of impulse. And CGS unit dyne second. As it is equal to change in momentum, even we can write kg meter per second or gram centimeter per second. Applications of impulse. While catching the cricket ball, cricketer pulls his hands back. Whenever they are taking catch, fielder taking catch, he won't keep hands quiet. He will drag his hands back. He will pull the hands back after catching the ball. So here he is increasing the time of action. So it reduces the force acting on his hands. Otherwise, his hands suffer injuries. Next, when a man falling on a sponge, pillow, or sand suffers less injuries because he has taken more time to reach the ground. Egg is dropped on hard floor breaks immediately, but the same egg is dropped on the sponge will not break. So in these cases, time is increasing. When time is increased, force will be reduced. Thank you for watching. Please subscribe for more updates.